Okay, for this lesson, we're going to start out with the basics, with functions, and what really is a function. And we're going to revisit the idea of domain and range. So we'll start off by determining what things are functions, what makes them functions, and then we'll look at the domain and range of specific types of functions. So today's going to be pretty basic. So it starts off with the first section here of what is a function. By definition, a function is a relationship in which each input has a single output. So for every input, there can only be one specific output. Otherwise, it's not a function. So from here on out, what we're going to be using is what is called function notation. So function notation is, it looks like this. It looks like f of x. It's written like that, f parentheses x. But what that really means, let me see if I can zoom here. What that really means is, f of x. Okay, so when you see f parentheses x like that, we've seen this before, but we've never really gone into detail with this. It's f of x. Now, what this is, and I'll just sort of rewrite it over here. See a different color. F of x. The x on the inside represents our input, while the entire thing will represent our output. So we input a number, and then what we get when we do the function is the output. So, for example, I have some room here. For example, if I have f of 5 equals 2, that means when 5 is inputted, the output is 2. And so that's what it means. And we're going to be doing this pretty much from here on out. We'll see things in function notation just like that. So, looking at specific examples to determine whether or not something is a function or not, remember the words here that for every input you can have only one single output. So the first thing you're going to look for in these, and let me see if I can make this a little bit thicker here. What you're looking for first is in the input values, the first thing you're going to want to look for is see if you have any repeating input values. Because every input can only have one output, if you have the same input twice with two different outputs, you're not going to have a function. So first you check and see that all of the inputs are different. Now in this case, all of my inputs, you see here, all the input values are different. Right away you can determine that this is a function. Because functions have every input value has a single output value, since they're all different input values, then it's a function. Well, at least with the data we have given. When we look at example 2, you'll notice that when you look at the input values, you have 0 on there twice. So that's the red flag that this is not going to be a function, but we want to verify. See, 0 is giving us 10 as well as 20. You have the same input giving you two different outputs. So general rule of thumb, look for repeating input values. It's generally going to not be a function, but double check and make sure that each input value has if it has different output values, then it's not a function. So not a function. Okay. What about graphs? You might have seen this in Algebra 1. With graphs, we have this technique which is called the vertical line test, which means if I draw a series of vertical lines, the lines only cross the actual graph one time. So notice the first line crosses once, the second line crosses once, the third line crosses once, crosses once, crosses once. So all of the 5 lines I drew cross the graph only once. And that's compared to if I draw a vertical line on the second graph on number 4, notice how it crosses 1, 2, 3 different times. So this right here would be a function, whereas this one here is not a function. So on a graph, you can easily check, see if it is a function by using the vertical line test. Let's look at the next page. Okay. So now let's look at domain and range. Here's where things are going to get a little bit more, to say, different than what you may have seen in the past. Most of you should have a basic understanding of domain and range. Domain is the set of allowable input values, or x. It's all the x values in a function. That is the domain. And by allowable, that's usually the function will set whether certain x values are allowable or not, and whether or not they're actually visible. So, and then range is the corresponding sorry for my handwriting, the corresponding set of output values. Or y. So today we're going to be focusing on 4 main functions. Now you're going to see moving forward in this semester, you're going to see all of these different types of functions again, and we will be recording their respective domains. So today it's just we're going to sort of do introductions here to what domain and range is for all of these 4 main functions. And you'll do even a lot more of this in pre-calc. For linear functions, as you see, both of those are linear functions. For linear functions, in general, let me zoom in. So this is, okay. In general, okay, domain and range, or domain / range, is all real numbers. Now this symbol might be familiar to some of you, probably foreign to most of you, but the symbol for all real numbers, I don't know why people just got tired of writing all real numbers, but it is an R with a line through it like that. That symbol means all real numbers. I'll put that in parentheses. All real, oh my gosh, real numbers. There you go. So, in general, linear functions will go to infinity in all directions. If you can imagine a line, any line, it is going to be going from left to right and up and down in both directions for an infinite amount. So the domain, the x values, and the range, the y values, is going to be infinite, or all real numbers. So for this particular linear function here, you see here 3x plus 5, once again, the domain is all, oops, I messed that up already, all real numbers. And range is also, I want to write all for all real numbers, but all real numbers. Okay, and same goes for the function below. Domain and range is all real numbers. Range is all real numbers. So now move over to quadratic. Quadratic, on the other hand, does not go in all directions infinitely. If you remember a quadratic being a U-shaped, there are parts of the graph where it doesn't go. So in general, I'll do this in a different color here, zoom in. In general, domain values, or x values, is all real numbers. But we have to look at the graph. For range. So this one's a little bit more complicated now. Domain for, in general, the domain for quadratics is going to be all real numbers, because the U shape does go left to right in all directions, but if you look at the height of a quadratic, it does not. So when we look at the domain and range here, f of x, the domain, like I said, 99% of the time, the domain is going to be all real numbers. But the range, we have to look at. So you have to look at the graph. So you would open up your graphing calculator, put this in your graphing calculator, and find the vertex. Remember, the vertex is the highest or the lowest point that your graph goes. And that's going to define your your range. Now, I don't have a graphing calculator available on this iPad, but I can show you where this is going to look if I were to draw a graph. So if I go over, I'm just going to go over here and sort of sketch this graph. If you were to put that in your graphing calculator, this is what you're going to see. So, see here. Make it mine. The minimum value is 0.5 and then negative 6.25. So 1, 2, 3, 4, 5, 6.25 and then somewhere right there. And the parabola goes up from there. I'm not really concerned at what the graph does above that, but this point right here, my minimum, is 0.5 and negative 6.25. So we're looking specifically, since we're dealing with range, we're looking specifically at this y value, since range is y values. So it looks like it starts at negative 6.25 and then goes up from there. So how we write that as far as range goes is it starts at negative 6.25 and then goes up, which means that your range is y is greater than or equal to negative 6.25. Okay, So what that means is it will include all y values greater than or equal to negative 6.25 because the graph does go in the upward direction. If it were going in the downward direction, it would be less than that, less than or equal to that. Let's look at the second example. Okay. So the second example, once again, and that's the domain, I guess in general the domain, it's always going to be the same, is all real numbers. Okay. But the range, we have to look at the graph. If we look at the graph is, and I'm going to do this a little bit quicker because you'll just see it on your graphing calculator. The graph goes somewhere like this, and then the vertex is right there, and it ends up being the coordinate 1.25, comma 6.875. Now again, since we're dealing with range and we are only concerned with range being the y value as we're looking at that, since the parabola does go in the upward direction, then it would be y is greater than or equal to 6.875 as my range. And that's quadratics. So a little bit different than linear. Domain is all real numbers, just like it is with quadratic and linear are both all real numbers for domain. But with quadratics, because the graph does not go in the y direction, infinite, both directions, we have to actually look at the graph, calculate the vertex to figure out where does it actually start. Okay, cubics, another easy one, just like linear, cubics in general. Let me get in here. Let's change the colors again. In general, domain and range are all real numbers. So just like linear, cubics, because they go up and down and their x values go left to right an infinite amount and their y values, one goes up and one goes down, they cover all ranges and domains. So our domain in general for cubics is going to be all real numbers, and the range in general will be all real numbers. And that goes same thing for the second example, all real numbers. Range is all real, oh my gosh, all real numbers. I always do that. Okay. The last one we're going to do, and you're going to see this during this specific unit, just later on in the unit, is radicals. Now this is where it gets tricky in both directions. So domain excludes numbers that give a negative in the radical. Range, oh my gosh, we look at graph. So some find this tricky, some not so much. I'm going to show you a little trick here as to how to figure out the range because you've sort of already done this before when we dealt with transformations of functions. But basically, what you want to look for, since this is a radical here, so then how it's a radical is because of obviously this radical here. But what we want to look for is what's inside the radical, because that's going to determine our domain. remember that radicals cannot be negative. They can't be less than 0. You could try that, do the square root of a negative number. It doesn't work. It gives you an error. So we can't have negative numbers in the radicals. So how do we determine what our domain is we just do this basic inequality here of 2x plus 4 has to be greater than or equal to 0. And it has to be. Whatever is underneath there has to be positive or 0. So we can solve for this. Subtract 4, 2x is greater than or equal to negative 4, divide by 2. So x has to be greater than or equal to, that's an equal to, negative 2. And that's our domain. So our domain is x is greater than or equal to negative 2. Now for the range, you can totally look at the graph, but here's my little trick. Remember, in transformations of functions, remember there was, let me do this in different color here. You had, we did this with quadratics, where it was y equals a parentheses x minus k squared. Sorry, not x minus k. Jeez, how long has that been? X minus h squared plus k, where h was your horizontal transformation and k is your vertical transformation. Now, the same thing happens here. We can manipulate this in that instead of having the square here with parentheses, the same form is in radical form if we do this. So you can easily see if the range changes by if there is a change out here vertically. Okay, so if you look at this particular equation here, there is no k value, so it has not moved up or down at all. It's 0. And if you put it in your graphing calculator, you'll see that the radical starts at a y value of 0. It has not been shifted up or down. So the k value is 0, meaning that the vertical change is 0, meaning that the range is 0. Well, it's not 0, it's just greater than 0. So our range is y is greater than or equal to 0. And if you put that in your graphing calculators, you'll see that the graph, and I'll just sort of draw what it looks like. Basically on a graph, it looks something like this. So you can see that it starts at 0. It starts at 0 here and then goes up. So y is greater than or equal to 0. And so we can do the same thing for the second problem, and this is the last thing here. First, we set what's in here equal to 0. So 3x minus 9, not equal to 0. It has to be greater than or equal to 0 because we can't have negative numbers. Add 9, 3x is greater than or equal to 9, divide by 3. So x has to be greater than or equal to 3. And that'll serve as our domain. So our domain is that x is greater than or equal to 3. The range, again, since there is no k value here, no shift in the upward or downward direction, it'll have the same range of y is greater than or equal to 0. If you were to graph this, you would see that the graph is like something like that. So again, it starts at 0 here and goes in that upward direction. If this was like a +2 or something like that on the outside, then it would be y is greater than or equal to 2. But it's not. So that's it. That is functions and determining whether or not something is a function or not. And then domain and range with some specific types of functions. Thanks.